Good morning, my name is Adekun Lajiboye. I'm here to present the walkthrough of my project titled Hybrid Modeling for Sales Prediction using SARIMA, CNN, LSTM, and Stack Ensemble. This project uses a publicly available Walmart dataset from Cabo, and it has some features such as external features such as CPI, fuel price, and temperature for weather, unemployment, etc. The library that were installed and the library that were used during the project. As a developer, I like to separate my project for easy reading. Here are the constants and the generic functions that was used within the project. I uploaded the data set from an Excel file into the pandas dataset, and it was displayed here using the head method. Here is the description of the data which was presented here, and the data was from Cargo was cleaned. It was stated that there was no missing data. So here is the graph to confirm actually there was no missing data sets. And here is the weekly sales trend over time. If you look at it, we discover that for the past, it covers 2011 to 2012, almost 2012, 10 to 2012, and we discovered that towards the end of the year there's always a spike. That's when we look at it around November. That's when we have the Halloween holiday, Thanksgiving, and Christmas, and there's actually drop in January. And we discovered that the same thing happens from what was in 2011 was also replicated in 2012. We discovered that there's more sales during the holiday weeks than the general week, that the sales distribution holiday versus non-holiday weeks. There's the stores as 45 stores. So we discovered that the total weekly sales by store, and we discovered that store 4 and store 20 most especially has the highest sales. Average weekly sales by stores, same thing here. Here we have average weekly sales by department. I've discovered that department 92 has the highest sales of them all. In the past 3 years, that's 2010, 2011, and mostly 2012, we discovered that the sales actually follows the same trend, whereby 2012 outperform other year. That's the monthly sales trend over the years, other years. So we have this distribution for each variables, each like stores, holiday, departments, weekly. So here is the distribution plot, and discover that so we also did the correlation. We did the correlation as a question, discovered that they actually fit perfectly well, except for some outlier, which is the 0.7 for the fuel price. Then we have the 0.78 for this 0.78 for the fuel price, and we have the 0.84 for the markdowns. That's promotional sales, markdown 1 to markdown 4. That's the correlation. So we discovered a strong positive correlation between the fuel and date, that's 0.77, which was stated above, between markdown 1 and markdown 4, 0.84, which was also shown above. Then we have the size and type, which is 0.81. Then moderate positive correlation between type and weekly sales. Size and weekly sales 0.24. Weak to negligible correlation with weekly sales. That's between temperature, fuel price, CPI, and unemployment rate. The correlation is weak to negative correlation. Then we have the negative correlation between CPI and unemployment rate, which is minus 0.3. Then we have this total. Those are that parts. Then we have others where weekly sales. We check for the outlier, and we check for the outlier, and the outlier was actually handled. We checked for the outlier, and the outlier was actually handled here. So after we plot it again before and we saw that layer, and after that layer we check for staircase. So we discovered that we also did the Fuller test for stationarity, and we discovered that the test is minus 6.6483, which is significantly lower and crucial. Excuse me. So we did the we generate the lag features and also rolling statistics for sales for previous weeks. So we did a lot of data cleaning, and we removed the I removed the not available numbers here and then so check what the impact, and discover after cleaning up the data there was 0 NAN number. So we also check for the power analysis to determine the required size sample. We discovered that the required size sample is actually 80% with 80% size and size 63, and this available sample is 421,563. So this sample size is sufficient for detecting the effectors for SARIMA. So and here is the power analysis curve, which is actually okay for development. So we start with the SARIMA. SARIMA use weekly aggregator. What I did was that to separate the data, I did a copy of the original pandas, that the sales. I did a copy and manipulate it, whereby making sure that the index is actually indexed with date, and then I sort it out, aggregate it into weekly sales, because SARIMA use a weekly sales data. So it was aggregated, and here it is for SARIMA. And we check for various seasonalities there. We check for seasonal decomposition, determine optimal SARIMA parameter, which was determined, and here is the best fit, which was employed in the project here. And training length 1141 data length. So and the application, it was applied at the what was gotten here was actually applied, and the training and prediction was done. And if you can see, it is actually now close. It's very close, it's just a bit slightly, which follows the trend, which shows that SARIMA actually performed without the 0.97 half-square score. And here are the other mean absolute error, mean square error, and mean squared error, root mean squared error. So we check for the residual of the SARIMA model. Then we'll go back to this. The next one is actually CNN. Also did the same thing by the copying it, make a copy of the sales data. And also CNN and LSTM use a daily data, unlike SARIMA that use a weekly aggregated data. CNN use a daily granular daily data. And the base model was defined, which needs more working on. So then I use a callback to prevent overfitting, learning rate, learning schedule. So everything was done. So the model was trained, and I use 50 ECOP after, because this training I use auto ML to get the best fit for this model. And here is what I have, which is 0.88. We discovered that it actually performed poorly, and this is the training and validation loss. The model didn't perform well, and we did the feature of forecasting, that the CNN prediction versus actual weekly sales. The same. So and the model was also same. So the same thing goes for LSTML. We also use AutoML and there was a copy that was made from the sales data as well, indexing dates, etc., and sorting, and it was also shipped. Also applies other functions to prevent overfitting, and the model was trained, and the model performed maybe slight better than that of CNN, but it also needs tweaking. If you can see, we have the 0.31, so future prediction. So that one as well, and we try to compare all of them together. That's see the SARIMA individually. This is the actual weekly sales, and this is the predicted weekly sales. You discover that SARIMA actually performed very well compared to other model, while CNN performed very poorly. If we check the prediction, the actual prediction is actually in daily for here, while this one is an aggregated data, while CNN and LSTM are daily actual sales, not weekly. So I try to use the Ensemble for all of them, try different methods to aggregate those data together, but the result was actually not good. So what I did was to exclude the SARIMA model, and by feeding both the LSTML into the meta-learner, that's XGBoost. And here is the result, the actual result, and the prediction for both LSTML and CNN, and these are the dates, because I want to use the date to track the root data itself. Discover that it outperformed both model, but still not that good. We still need a lot of work on. Then did a forecast prediction for the meta-learner. So the SARIMA model that was not fed into it directly with the LSTM and CNN was actually what I did was did an hybrid model of SARIMA and XGBoost model. And when we check the prediction, yeah, it performed better. It performed better. But SARIMA, the single model, actually outperformed, so that's 0.71. SARIMA as the single model outperformed XGBoost, that is the outperformed the hybrid model, which we also need some tweaking. Time is actually a factor in this project, time. So if you can see, these are the SARIMA, LSTM, and CNN and LSTML in summary. The performance comparison CNN, LSTML, and meta-learner, SARIMA versus hybrid, and we have the performance meta-learner versus hybrid. So that's the end of it. Thank you.